Hello everyone, welcome to today's video. We are back with yet another demo video as a proof of concept. We are excited to show you a fantastic application which utilizes state-of-the-art machine learning techniques. This app is designed to perform semantic segmentation on images specifically for clothing items. So let's dive right in. But before that, let's just quickly take a look at what all we will be covering in this video. So we will talk about the model that we are going to use, which is called Segformer B2. Then we will discuss who can benefit from this application. Then we will take a look at the demo of the application, following which we will discuss the code. So let's start. This app uses an open source model from Hugging Face called Segformer B2. This model has been fine-tuned for cloth segmentation, meaning it's trained to identify and segment different clothing items in an image. This model is based on a transformer architecture which is optimized for handling complex visual data like clothing textures and patterns. And moreover, this model employs state-of-the-art deep learning algorithms to identify and segment different types of clothing within images. Now let us take a quick look at the model card for this model on the Hugging Face website so that we get to know this model better. So this is the page for the Segformer B2 model on the Hugging Face website. And here we can take a look at the model card for this particular model, where it has been mentioned that this model has been fine-tuned on the ATR dataset, and the link to this dataset has also been provided. So if you want to take a look at it, you can click on it and check this out. The GitHub link where this particular dataset has been hosted is provided. Also, it has been mentioned that this particular model can also be used for human segmentation. Apart from that, here it has also been mentioned that this particular dataset is also present on this particular website, and the name of the dataset is this. So by using this name, you can search it on the Hugging Face website as well by clicking here and going to the dataset section. Then next in the model card, we have some training code where a code snippet has been given showing how we can use this particular model for cloth segmentation. And here the information about the labels which can be identified using this model has been provided. So in total there are 18 labels starting from 0 to 17, which represent a different type of clothing and some other scenes as well, like background and so on. So these are the labels that can be currently predicted by this particular model, and these are the index for these label names. In this table we can see the label index, the label name, and the accuracy of the model in detecting these categories. So this is the evaluation for this particular model, and this is the overall evaluation matrix, that is the average of the results. So we can see here that the mean accuracy of this model is 80%, which is fair enough. And then we have the IOUs as well and evaluation loss too. So all in all, this model is performing pretty well, and the value of these metrics are very reasonable. And also the performance of this model can be further improved by training the model for longer or by introducing more comprehensive and better data at the time of training to the model. So these are the few factors using which we can improve the performance of the model, but currently in this state also it is performing fair enough. Then here we have some bibliography. Now coming to this section here, we can see how many times it was downloaded last month, and the number is quite big. So it is being utilized by quite a lot of people actually. And here we have the inference API where we can try this model out. For doing so, you need to log into your Hugging Faces account. Then you will be able to use this particular API to see how this model works. So here we have few examples. There's this one image and then the second image here, and we can choose any. So this is the image that has been chosen. And it will take a bit of time. and here is the result. This is the segmented image, and you can see that different color corresponds to different category. The pants are blue. You can see here, like only the pant is highlighted in this particular image. If I select hair, then only the hair would be highlighted. Here are the upper clothes. This is the background, the right shoes and the left shoe. So these are the labels which have been identified and segmented in this particular image. Similarly, we can take a look at the second image as well, how it's going to be segmented. Again, we have background in the red, then we have hair and the upper clothes. See, the accuracy of identifying these labels or categories in this image is 100%, and we can see that it is almost accurate, right? So this is how the model works, and you can integrate it into your existing applications, or you can build on top of this particular application or fine-tune it to make something completely new. Moreover, on this page you can also check the files and versions of this particular model, and then the community support for this as well. And you have the option to train and deploy this particular model on different platforms. So do check out this page if you are interested in utilizing this particular model and want to know more about it. Now let's move on to the next topic, which is who can benefit from this application. This tool offers significant advantages for students, developers, and businesses in the fashion industry. Firstly, students can greatly benefit from using this application, whether they are trying to conduct research projects in computer vision or looking to enhance their AI skills. This tool provides a robust platform for learning and experimentation. Next, students can also use this in educational purposes, where they can use this tool to delve into image segmentation techniques, understand deep learning models in practice, and build impressive projects for academic portfolio. By working with the state-of-the-art model like Segformer B2, students gain hands-on experience with cutting-edge technology, preparing them for future careers in AI and machine learning. Next, developers will find this application highly versatile and practical. They can use this in application development, where they can integrate clothing segmentation into existing applications to enhance functionality and user experience. For example, you can develop apps that automatically categorize and tag clothing items in images. Additionally, developers can offer segmentation as a service through APIs, providing other developers and businesses with powerful image processing capabilities. Moreover, they can customize and extend the segmentation model to fit specific business needs or to explore new features and improvements. This flexibility makes it an excellent tool for rapid prototyping and innovation. Finally, businesses in the fashion industry can use this tool to achieve operational excellence and improve customer engagement. Fashion retailers can streamline inventory management by automatically categorizing clothing items from product photos. This automation reduces manual effort and enhances accuracy in product listing. Also, fashion designers can use this tool to visualize clothing interactions, aiding in the design process and trend analysis. This visualization helps in creating more appealing and cohesive collections. Next, e-commerce platforms can significantly improve user engagement by offering enhanced search capabilities and personalized recommendations based on accurately segmented clothing items. And lastly, content creators such as bloggers and influencers can leverage this tool to create visually captivating content, enhancing their online presence. By segmenting clothing items, they can apply unique effects and highlight specific pieces in their content. In summary, this clothing segmentation application is a valuable asset for a diverse range of users, from students and developers to fashion businesses and content creators. By using the power of AI-driven image segmentation, you can unlock new possibilities and efficiency in your projects and operations. Moreover, by utilizing this app, users can automate and enhance tasks such as inventory management in retail, design visualization in fashion, and content creation in digital marketing. The application's accuracy and efficiency contribute to improved user experiences on e-commerce platforms and streamlined workflows in fashion design and retail sectors. Now it's time to move to the next section, which is the demo. So now let's see the app in action. So this is the interface of the app that we have created. It is quite basic, and here we have the section where we will be showcasing our uploaded image, and here the segmented image will appear along with the labels which have been detected in that image for the segments. And here we have the option to clear the image if we want to go for another image. And let's just see it in action. So I'm going to upload an image, and you will watch as the app processes the image to identify and segment the clothing items. So if I click in here, I can also drop an image as well. So let's just pick any image. So I have selected this image, and now I click on the submit button. You can also see that the elapsed time is also being calculated in here. So in almost 10 seconds, this particular image was segmented, and here you can see that different parts of this particular image have been identified and are colored differently. So you can see here that the face has been identified as green, and this is the case here. Like, we can verify that this is correct. Then we have the hair, which is of purple color, and then the background is yellow, and then we have the left arm, which is blue, and the upper clothes, which is navy blue basically. So this is how the app works. We can choose another image as well. Let's just go with one more image. Here also we can see that upper clothes and the lower clothes, which is the pant, has been identified in here. And then we have the left and right legs as well, and the shoes have also been identified in here. You can see that the left shoe is in purple, light purple color, and the right shoe is almost black. So this is how this app works. So as you can see, the model quickly identifies the different clothing pieces and segments them accurately. The output image clearly shows the segmented areas. Here we can verify this with the labels which have been present in here along with the image, segmented image. And we could see that it almost takes approximately 10 seconds to segment an image. So the Segformer model's architecture enables efficient processing of images, making it suitable for real-time applications and large-scale image datasets. So the Segformer model's architecture enables efficient processing of images, making it suitable for real-time applications and large-scale image datasets. We come to the next topic, which is the code overview. Here we will take a quick look at the code behind this app. So the app is built using Python and utilizes the Hugging Face Transformers library for loading the Segformer model. We also use Grade.io for creating a simple user interface. So that is why we start by installing these two libraries, the transformer library to get access to the Segformer model and the grid.io library to create a simple user interface for the app. Once we are done installing these two libraries, we import some necessary functions and classes, and then we start off by loading the pre-trained Segformer image processor. Here we can see that in the second line of the code that we are storing the pre-trained Segformer image processor in the processor variable here, and we also load the Segformer model. So in the third line here, in this cell, we are loading the pre-trained Segformer model, which has been fine-tuned for segmenting the clothes. Once we have the processor and the model, we move on to the segmentation function. The function segment image processes the uploaded image, performs the segmentation, and returns the segmented image. So this is what is happening here. And before that, here we have listed down the classes which can be identified in this particular segmentation task. So as we have already discussed in the model card section, that this particular model, that is Segformer B2, can identify 18 classes or categories of clothes, out of which one is the background and the rest is hat, hair, sunglasses, and so on. So these class labels have been listed in here, and here we are randomly assigning the colors to these labels, okay, and whatever would be the color of these labels, the segmented image would show that particular color in there. So for example, let's say if hair is green, like if the label color for hair is green, then in the segmented image, wherever hair is identified, it will be shown as green. So currently we are just randomly assigning the colors. So in each run of the code, the color for hair would be different. So because it is being randomly chosen basically. So this is what we are doing here before the segment image function, and then in the segment image function we are processing the image, we are passing it as the input to the processor, and then we are getting the output from the model along with its logits, and we then simply plot the segmentation map to create the segmented image. So this is how the segment image function works. Then we move on to the next cell, which is the grid.io interface. So here we are doing nothing but creating the interface for our app, which we have already discussed. So this was the interface for our app, this here, okay. So you can see here that with just 4 lines of code, we were able to create such an interface for our app, a very simple user interface which does its job very beautifully. And here you can see that with grid.io we can just create the interface in the notebook itself. So this is the Jupyter notebook in Colab where we have created this particular interface, but we can also see this interface on this website as well. So if you want to go full screen with it, then you can just use it here. Again, you can just choose any image, submit it, and here is the segmented image. So with this simple setup, you can create a powerful image segmentation tool in just a few lines of code. So this solution is cost effective because it uses a pre-trained model from Hugging Face, reducing the need for extensive computing resources and time for training. Additionally, the grid.io interface simplifies the development process, allowing for rapid prototyping and deployment. So at this stage, this particular application is being shown as a proof of concept, but it can be improved further. We can add more categories into it, where instead of just saying upper clothes, we can get more into detail by categorizing those upper clothes into tops, t-shirts, blouses, and so on. So let's talk about the cost effectiveness of this particular application. So this solution is cost effective because it uses pre-trained models from Hugging Face website, and this model is an open source model which reduces the need for extensive computing resources and time for training. Additionally, the Grade.io interface simplifies the development process, allowing for rapid prototyping and deployment, but you can use any other library of your choice to create the user interface. Then if we talk about the advantage of this app, then we see that the Segformer model is highly accurate in segmenting clothing items. And we also see the ease with which we can use this app. The app is user friendly, requiring minimal technical knowledge to operate. You just need to upload an image to get the segmented image. And if we talk about scalability, this solution can be easily scaled to handle large volumes of images. Also, if we are to discuss the limitations of this model, then the model is specifically fine-tuned for clothes segmentation and might not perform as well on other type of images. And it is a bit of resource intensive as well. Running segmentation models can be resource intensive, especially for large images or batch processing. So currently we are using only one image for segmenting, so it is being done in under 10 seconds. But as and when the amount of images which are to be segmented increases, the time would increase as well, and so would the resources required to do that. So this is some of the limitations that needs to be considered. But all in all, it's a really good deal. We can do wonders with this open source model by fine-tuning it and creating more incredible and efficient apps. So all in all, this particular model is a deal breaker since it is cost effective, pretty fast and very easy to use. We can use this model as it is, or we can fine-tune it to perform better by providing it more better data and training it for a longer time. Moreover, this application integrates seamlessly with Python-based frameworks and libraries, utilizing Hugging Face transformers for model loading and inference. And the model's architecture enables efficient processing of images, making it suitable for real-time applications and large-scale image. Lastly, I would like to thank you for watching this demo. If you are interested in implementing this solution or need assistance with similar projects, feel free to reach out to Codersarts. Our team of experts is here to help you bring your AI and machine learning ideas to life. You can contact us via our email ID, which is contact@codersarts.com, or you can visit us at www.codersarts.com for more information and to get started on your project. You can also find our LinkedIn, Instagram and Facebook handles in the description box down below. And please don't forget to like, share and subscribe for more such videos. It keeps us motivated. Thank you.